Good morning, everyone. Thank you, Lorena. Thank you, Cesar. In this presentation, I would like to explain the progress about the development of an artificial vision system prototype with the aim to characterize the granulometry in the aggregates industry, and has been developed and tested within the ROTATE project in the Belde pilot site in Norway. Why it is important, this solution? We had to take into account that in the mining and aggregates processing stages accounts for between 50 and 70% of total crushing energy consumption. So in this sector, the energy optimization is a strategic priority for increasing competitiveness and sustainability. About the current methods for control granulometry nowadays, most of all are based on crushing and screening using mechanical sieving or intermittent sampling. This means that they are using manual granulometry. And the disadvantages of these methods are they are slow, labor intensive, and produce inefficient crusher settings, providing data that are neither continuous or not representative of the actual material flow. So at the end, this manual granulometry control translated into up to 15 energy losses, as well as frequent equipment failures and increased maintenance costs. So the industry, the aggregates industry, is demanding and looking for new solutions that are automatic, non-invasive, and allow real-time monitoring capable of detecting the PSD, the particle size distribution, under harsh industrial conditions. With this objective, we have developed a real artificial vision system, the AVS, to measure in real time granulometry and volume process. Our more innovative solutions include customized and adapted algorithms that optimize the crusher performance in real time, reducing operational cost and environmental impact. These are some photographs of the installation of the artificial vision system in the pilot in Belde in Norway, in the outlet of the secondary crusher. The aim is not only to measure particle size, but to actively optimize energy consumption and operational efficiency of the aggregates processing plant through the AI-driven optimization of crushing processes, introducing real-time monitoring of particle size distribution and connect this information directly to automated crusher control. And at the end, this solution enables the dynamic optimization of crusher operation, reducing energy consumption and carbon dioxide emissions. The system follows a closed-loop architecture. It's a scalable solution that integrates hardware and digital technologies. First of all, the data are acquired using a 3D optical profilometer. Then the data are processed using artificial intelligence algorithms. And finally, these data that are stored in the cloud are processed and used to adjust the crusher parameters in real-time feedback. This is an example of a particle analyzed during the process of granulometry control. As I said, the system was installed at the secondary crusher outlet in Belde facilities and operated autonomously, taking several data and monitoring and cloud-based data storage, controlling the particle size distribution, the volume that has been processed, the flow rate of the conveyor belt, the particle count, and the energy consumption at real time. No manual calibration was required, and we can provide with the system statistically representative data, unlike traditional sampling. So the key innovation is combining 3D optical sensing and artificial intelligence-based granulometry estimation. That is working and has been validated under harsh industrial conditions such as dust and vibrations. We had tested in Belde different crusher openings to optimize the energy consumption and CO2 emissions without compromising the product quality. And the results are that up to 30% energy savings and CO2 reduction was achieved. They are higher values because at the beginning of the project, whereas our estimations were lower, but we have reached up to 30% energy savings and CO2 reduction in the last test carried out at the beginning of 2026. And the system also has contributed to reduce wear and improving operational stability of the crushing stage. The CO2 emissions are calculated based on the real-time measured electrical energy consumption of the crushing process, combined with a standardized emission factor derived from the life cycle assessment methodology that is in progress in Belde. So in the table, we had an example of the different data acquired for the processing at real time. At the same time, we can estimate the CO2 emissions per ton of processed aggregate under different operated conditions. So we can compare the results for different crusher openings and quantificate the environmental improvements achieved through the system. These are the results of the pilot test in Belde in 2025. We can compare the energy consumed at real time at in the secondary crusher for different crusher openings, as well as the CO2 emissions per ton. And these are the results for the piloting in 2026. So what are the impacts and benefits of our solutions? We have tested and validated that the system enables the digital transformation of the crushing process, allowing not only continuous monitoring, but also we can study the trend analysis and also to make a future predictive optimization. So we pass for a reactive to a predictive working of the aggregates process. The system has been successfully validated at industrial scale, demonstrating measurable improvements in energy efficiency emissions, and the obtained granulometry was within the required thresholds for downstream processing. The system is robust, has been tested under dust, vibration, and real plant conditions. It is scalable as is based on standard industrial components. We can conclude that this is better than existing solutions as allows continuous full flow measurement versus sampling. And for future work, we are working in the integration and full automation of the process, integration into higher level control system, and scaling across different plants, not only for aggregates plant, but for any industry that is processing solids. On the other hand, the solution has a low-risk investment for the mining and aggregates operators, and it's aligned with the European push towards sustainable and digital raw material sectors. There are several benefits related to the installation of the system in the industry, operational cost savings through the energy saving and maintenance optimization. The system improved the process stability and quality control, increasing plant throughput and reducing downtime. The environmental performance gains in line to the corporate environmental, social, and governance targets and regulatory compliance. And in terms of enhanced safety and reputation, strengthening the social license to operate in the mining sector. And finally, the solution aligns with several macro trends at the European level, such as the energy transition and decarbonization, in line with the European Green Deal and Repower Europe, incentivizing energy efficiency and CO2 reduction in industrial processes. It contributes to the Industry 5.0, to the digital transformation, with the integration of IoT, AIs, and sensor technologies, creating a strong demand to a smart control system in a traditional sector. It contributes to the workforce safety and automation, as the system allows the remote monitoring, reducing the human exposure to hazardous environments, addressing key occupational safety priorities at European level. And finally, the real-time process controls supports the resource efficiency and circular economy in line with the Sustainable Development Goals. Okay, this is all from my side.